That's the power of one of these asteroids. 10,000 Hiroshima bombs is the power packed by this piece of real estate a mile across. Oumuamua, a mysterious entity that once zipped through our solar system, has again sent shock waves throughout the scientific community. Elon Musk, a prominent innovator in space technology, revealed that Oumuamua is back, and this time it's not alone in its journey. Elon Musk claims that its hidden characteristics contain a tantalizing hint regarding life in other star systems. This isn't the conventional return of a celestial entity, it's a return that challenges our understanding of space and its potential occupants. Join us as we unravel the implications and mysteries surrounding Oumuamua's unexpected reappearance. Back in 1837, an unusual object reached a notable cosmic milestone. It crossed a distance of 1,000 astronomical units from the Sun. For over a century, this object continued its journey unnoticed, steadily advancing towards our star. It wasn't until October 19, 2017, that humanity finally became aware of its presence. On that particular day, an image captured by the Pan-STARRS 1 telescope at the University of Hawaii revealed a faint, delicate streak traversing the sky at a consistent pace, covering approximately 6.2 degrees each day. This marked a historic moment. It was the first recorded interstellar visitor, officially designated as 1IA 2017 U1. This object was also given the name Oumuamua, which translates to a messenger from afar arriving first in Hawaiian. The revelation sparked a global initiative to observe Oumuamua through telescopes. Astronomers, including those from the SETI Institute, eagerly engaged in observing the object, even launching searches for potential extraterrestrial signals. Oumuamua looked like a reddish cigar-shaped object made up of rock. Its elongated shape is striking, stretching up to 4 miles long and about 10 times longer than it is wide. Oumuamua has an aspect ratio that surpasses any asteroid or comet observed in our solar system. Oumuamua was traveling at a speed of 196,000 miles per hour when it got close to Earth. That's 109 times faster than a bullet, which means there's no way this object was part of our solar system all this time. Scientists couldn't initially determine if Oumuamua was an asteroid or a comet. Comets are composed of ice while asteroids are rock. Initially, scientists thought it was a comet, but their classification changed to calling it an asteroid once it zipped past the Sun on September 9, 2017. However, they still considered it an asteroid until additional measurements indicated slight acceleration, which is a sign of it being a comet. A remarkable characteristic of Oumuamua was its periodic brightening and dimming every 7.3 hours. This dynamic behavior indicated its rotation around its short axis. Such a rotation pattern suggested a more rigid and durable composition than the typically fragile, snow-like material of most comets. Appearing dark red, similar to certain moons in the outer solar system affected by space radiation, Oumuamua's color might also involve iron, as suggested by Dr. Meach, an astronomer at the University of Hawaii's Institute. Despite these insights, Oumuamua's origin and nature remain a mystery. Its trajectory confounded scientists, hinting at something beyond natural explanations. Various theories emerged to explain Oumuamua's identity. While some believed it to be a rock, others proposed it was composed of gas. Astonishingly, a subset of experts even entertained the possibility that it could be an alien spacecraft. This raises the intriguing question, could an extraterrestrial mothership be navigating our solar system and deploying smaller probes to explore planets? In the subsequent segment of this video, we will delve deeper into these mysteries. But first, let's examine the range of scientific propositions that have been put forth to decipher the origin of Oumuamua. Dr. Meach proposed the idea that it might have been flung out from a distant star following a supernova explosion, or perhaps formed when two objects collided and fused. According to Elon Musk, astronomers were initially excited when they observed that the trajectory seemed to point toward Vega, the brightest star in the Lyra constellation. Known to possess a debris disk, calculations indicated that this entity could have traveled from Vega to our location in roughly 600,000 years. However, the likelihood of Vega being the actual source has diminished due to significant changes in its path. It's believed that Oumuamua encountered a new star system for the first time, considering its motion about the Sun, which was akin to the speed of nearby stars. Nonetheless, there's a possibility, as suggested in Nature, that Oumuamua might have been journeying around the galaxy for billions of years. We're uncertain about its upcoming trajectory. Imagine it like this: remember how the Voyager spacecraft received a boost in speed from Jupiter? Well, Oumuamua is also gaining momentum from the Sun, propelling it faster and in a different direction. Dr. Meach clarified this: this asteroid, along with its counterparts, revolutionizes our view of the galaxy. Picture this: when you look up at stars seeming distant and isolated, it contrasts with what these asteroids unveil. They remind us that things are interconnected and intriguing. The oxygen and iron within our blood emerged from a massive explosion in a distant place long ago. The golden items like wedding rings resulted from the collision of superdense stars, and those meteorites plummeting to Earth, some of them originated from Mars due to asteroid impacts. Remarkably, some esteemed scientists contemplate that these meteorites could have carried life from Mars to Earth during a time when Mars enjoyed warm and wet conditions. Life might have begun there and then hitchhiked on those meteorites to Earth. It's an audacious concept, yet it's being pondered by respected astronomers. Our connection to the cosmos can be traced even further back in time. Think about the hundreds of thousands of years Oumuamua might have taken to arrive here. While that might seem lengthy, it's merely a fleeting moment on the cosmic scale. The Milky Way galaxy boasts an age of 10 billion years. Over this immense timeframe, Oumuamua could have journeyed through approximately 20,000 star systems, a modest fraction compared to the galaxy's 200 billion stars, but still a significant number of cosmic encounters. Oumuamua would have trailed behind dust and debris, allowing the stars and the worlds of the galaxy to intermingle. This suggests that the universe might be smaller in scope than previously thought. Even if it's no longer within our immediate view, the solar system hasn't let go of it just yet. Elon Musk and other astronomers predict that Oumuamua will enter the Kuiper belt around 2024 and cross its edge by late 2025. He also estimates that it will pass Voyager's most distant point in 38 years. However, since Oumuamua has been out of reach for astronomers, they are making the most of the information gathered in just a few months to comprehend as much as possible about this intriguing interstellar intruder. Initially mistaken for an asteroid due to its size of about 2,600 feet in length and 260 feet in width, Oumuamua exhibited unconventional behavior in its trajectory. Astronomers and scientists observed a notable non-gravitational acceleration indicating that forces beyond gravity were at play in its motion. Dr. Meach explained that several factors could lead to this acceleration. Her team investigated at least 6 potential causes, eliminating some due to their implausibility or inconsistency with observations. One likely explanation was comet outgassing, a common occurrence in comets. Outgassing happens when a comet approaches the Sun and its surface ice sublimates, turning directly from solid to gas. This process gives the comet an additional push, altering its speed and rotation beyond gravitational influence. This change in motion resembles the behavior of Oumuamua, aligning with the power observed in comets. Notably, the lack of emerging dust from Oumuamua was intriguing. Typically, as gas exits a comet, it carries surface dust with it. However, Dr. Meach asserts that even if the comet lacked microscopic material, the potential presence of substantial dust on its surface might have been affecting its speed. This consideration kept the idea of it being a comet alive. Additionally, scientists primarily examine visible wavelengths, which make it challenging to detect significant dust particles. Consequently, no visible evidence of dust leaving Oumuamua was observed. The absence of gas-related indications was also puzzling. Surprisingly, astronomers expected a noticeable amount of gas emission to influence Oumuamua's velocity in the manner observed. Dr. Meach's team specifically searched for CN gas, a substance that she notes is bright and easily identifiable. It serves as a proxy for water, which is harder to monitor since CN is often released from comets in our solar system alongside water. Curiously, despite their efforts, no CN gas was detected within their detection limits. Considering that comets in our solar system can hold significant amounts of water, the strong upper limit set by the absence of CN gas indicated that this comet was chemically exceptional. Dr. Meach explains that if a large volume of water were to be emitted, it would likely originate from a different solar system. and this could account for this unusual finding. Astronomers utilized the Spitzer Space Telescope to observe Oumuamua in the infrared for over 30 hours, attempting to detect its thermal characteristics. However, they encountered challenges in their endeavor. Dr. Meach explains that the thermal infrared detects heat emissions, and in this case, their observation didn't yield any noticeable results. Interestingly, even non-detections can offer insights. In this case, they deduce that Oumuamua must be brighter than anticipated if it exhibits thermal behaviors akin to a comet. The reflectivity of an object, or how much light it reflects, can reveal details about its size, composition, and shape. We always assume the reflectivity resembled that of comets, which is very low, Meach explains, but they were getting readings around 10% reflectivities instead of the usual 4% reflectance typical of comets. So once again, it doesn't quite fit the profile of a comet. To make it match that 4% reflectivity, you'd have to assume it has very different thermal properties on its surface compared to other comets. This is another intriguing oddity. Furthermore, during the same infrared studies, no detectable carbon monoxide or carbon dioxide outgassing from Oumuamua was observed. This finding holds significance since Meach's team had been considering the possibility that Oumuamua was releasing these two gases in larger quantities than the Spitzer's observation limit suggested. According to Meach, it's a bit challenging to infer too much from what you don't see. But again, it doesn't seem to behave like a regular comet. Given that Oumuamua hailed from a different solar system, these anomalies could be characteristic of objects originating from other star systems. The trajectory of Oumuamua was meticulously traced back to before its initial entry into our solar system by Corinne Baylor-Jones from the Max Planck Institute for Astronomy. Comparing this path to the past positions of 7 million stars tracked by the Gaia spacecraft, Baylor-Jones rewound both Oumuamua and the star's orbits to identify potential points of overlap. Out of the stars with trajectories that approached close enough to Oumuamua's rewound path, 4 contenders stood out as possible candidates for its home. Elon Musk claims that Oumuamua's course had intersected within a range of 1 to 2 Oort cloud rafts, or 100,000 to 200,000 astronomical units. However, as Baylor-Jones was stargazing, complications arose. The encounter velocities of these contenders were relatively high, spanning from about 6 to 16 meters per second, a potential setback. Oumuamua is most likely a planetesimal, a building block cast out during the formation of planets. It's uncommon for planetesimals to attain ejection velocities this high solely through interactions with large planets. While these velocities are high, they are not impossible, yet quite unlikely. The scenario becomes more plausible if Oumuamua originated in a binary star system. However, none of the contenders were recognized as binary stars. Naturally, forthcoming data releases from the Gaia mission could assist astronomers in identifying a more suitable source for Oumuamua by offering deeper insights into the motions of nearby stars. In a few years, it would be fascinating to revisit this, the first and so far only extraterrestrial visitor we've observed traversing our solar system remains Oumuamua. Even with the limited data available, despite its enigmatic nature, experts worldwide are intrigued by its potential secrets. Undoubtedly, Oumuamua continues to captivate due to its peculiar characteristics. Now, it turns out that Oumuamua is not on its own. Back on August 30, 2019, Gennady Borisov, an amateur astronomer at the Margot Observatory in Crimea, spotted a new comet named Two-Eyed Borisov. This comet was racing through space at an astonishing speed of 93,000 miles per hour, 150,000 kilometers faster than what you'd expect for an object situated about $2.80 away from the Sun. What caught our attention besides its speed was its trajectory. It was plunging into the inner solar system at an angle of 40 degrees relative to the ecliptic plane, on an orbit marked by an incredibly high eccentricity of 3.7. This indicated that similar to Oumuamua, Borisov also had an extrasolar origin distinct from our solar system. Borisov displayed a clear tail, unmistakably marking it as a comet. Its journey was taking it toward the Sun, projecting to reach its closest point on December 8, 2019, at approximately $2 from our star. This meant it would brighten before dimming again, possibly reaching magnitude 15 by its closest pass to Earth on December 28. Even after it dimmed for amateur observers, professionals could continue tracking Borisov until October 2020. Dr. Meach's team already observed Borisov and estimated its size to be between 1.2 and 10 miles. In October 2019, they noted the emission of CN gas from its surface, though the comet's faintness prevented detecting other gases. However, the long year of observation provided by 2I's trajectory offered a unique opportunity to explore its chemistry. This stands in contrast to Oumuamua, which didn't allow for detailed chemical analysis due to potential hindrances due to gas and dust. This extended observation will shed light on 2I's characteristics. What sets 2I apart is its distinct comet-like appearance, making it a red-hued traveler that aligns more with our typical understanding of solar system comets. This divergence highlights the diversity in interstellar objects. Such differences are invaluable for astronomers striving to understand the processes shaping other solar systems, whether similar or distinct from our own. This ongoing exploration expands our perspective on the broader cosmos. Meanwhile, some astronomers have ventured to suggest that Oumuamua might be of extraterrestrial origin. Adding to the intrigue, a draft article by a Harvard scientist and the head of the Pentagon's UFO office proposed the possibility of an extraterrestrial mothership within the solar system, dispatching microscopic probes akin to dandelion seeds to explore the planets. The revelation of this document came from Sean M. Kirkpatrick, the director of the Pentagon's All-Domain Anomaly Resolution Office, AO, established in July 2022 by the Department of Defense, DoD, to identify and investigate intriguing objects. Collaborating on this draft study alongside the DoD was Avi Loeb, an astronomer at Harvard University. However, it's important to note that the study is not an official Pentagon document. Loeb is renowned for his research on Oumuamua, having even suggested the idea that Oumuamua might be an extraterrestrial spacecraft 6 months before Oumuamua's close approach to Earth. A small interstellar meteor, approximately 3 feet in diameter, struck our planet. Although unrelated to Oumuamua, this meteor, known as M2, caught Loeb's attention by chance. Loeb considered the possibility that an artificial interstellar object could serve as a parent craft, releasing numerous small probes during its passage near Earth, a concept akin to NASA's spacecraft missions. The tidal gravitational force from the Sun or the craft's propulsion might detach these dandelion seeds from their parent vessel. In their draft study, Loeb and Kirkpatrick delved into unidentified anomalous phenomena, UAPs, a term preferred by the government for UFOs. While adhering to established physics, the scientists hypothesized that the dandelion seed probes might travel to Earth for observation without being detectable by survey telescopes, likely due to their small size, which would limit their sunlight reflection. According to their proposal, the technology of these probes could enable them to slow down in Earth's atmosphere to prevent burning up, subsequently utilizing their parachute-like features to navigate to their intended destinations upon landing. Scientific conjecture suggests that alien civilizations might desire to study rocky planets with atmospheres within our solar system. Planets like Venus, Earth, and Mars would undoubtedly pique their interest. After detecting signs of liquid water, the mothership wouldn't necessarily need to be home to the advanced extraterrestrial civilization that created the probes. The possibility of the mothership communicating with these probes is also dubious. The notion that a habitable planet with intelligent life might have dispatched probes long before Earth existed is an intriguing proposition. Loeb likens it to periodically checking our mailbox for accumulated packages, even if the senders are no longer extant. Loeb has faced skepticism from the scientific community since he first proposed the idea that Oumuamua could be an alien spacecraft. Some critics view his hypothesis that Oumuamua was intentionally sent to Earth as provocative and lacking a solid foundation. In 2021, a letter published in the journal Astronomy and Astrophysics refuted the feasibility of interstellar travel, citing cosmological time scales required to traverse between stars. The authors concluded that it's unlikely Oumuamua was sent by an extraterrestrial civilization, more likely attributing it to an unusually shaped rock that happened to wander into our solar system. Another analysis has effectively debunked the notion that Oumuamua's enigmatic movements could be attributed to an extraterrestrial spaceship. Instead, it provides a plausible explanation, suggesting that hydrogen off-gassing, which occurred on March 22, 2023, is the likely cause behind the peculiar behavior. However, recent times have witnessed the Pentagon renewing its focus on investigating mysterious aerial phenomena within American airspace. Since its inception last summer, the All-Domain Anomaly Resolution Office, AO, has initiated over 360 additional inquiries into reported encounters with unidentified aerial phenomena, UAPs, by U.S. military personnel. Approximately half of these cases have been attributed to balloons or similar objects, while the remaining half lacks sufficient data for a conclusive determination. In the quest for understanding, figures like Elon Musk hold the hope that advanced telescopic scans might unveil more extraterrestrial objects. These discoveries could provide valuable opportunities for researchers to put their hypotheses to the test. The parallels with exoplanet discovery offer an encouraging precedent for such endeavors. Merely 2 decades ago, the first exoplanets beyond our solar system were discovered. In just 20 years, our understanding has expanded dramatically, confirming the existence of over 4,500 exoplanets. This trajectory underscores the rapid progress made in the realm of celestial investigation.